Hello, thanks for joining. My name is Dugald Morrow. I've been at Atlassian for about 9 years. I'm a developer advocate now, but I've been in engineering roles for most of my career. Today, I'm keen to talk about establishing extensibility standards. I realise this is a somewhat vague title, so let's dive in to disambiguate it. The agenda is pretty simple. I'll start by providing some context, then I'll outline challenges, solutions, and finally lessons learnt along the way. Providing some context will help you understand the challenges we've faced, as well as our path to solving these challenges. Before joining Atlassian, I had read posts by Atlassian on all sorts of things such as agile best practices. I assumed Atlassian teams would be consistently adhering to methodologies such as Scrum, but in reality, this wasn't the case. Internally, it was closer to organized chaos. Teams were empowered to choose and make up processes, resulting in very organic environment with little standardization. That was quite a while ago, but Atlassian teams still enjoy a lot of autonomy. There are many benefits of this culture, but as we'll see later, it also introduces challenges. At a high level, Atlassian is a product company. We have quite a few products with a lot of customers. But this picture is an oversimplification because Atlassian's marketplace is a huge part of our success. Our products have rich APIs that are used by a large number of apps and partners. Lots of these partners are large organizations with many developers. In addition, there are a huge number of individual developers that create apps for their own needs or the needs of their organizations they work for. The Atlassian marketplace is one of the largest enterprise software marketplaces, with customers installing over 28,000 apps per week. But despite this success, Atlassian is still a developer plus company, not a developer first company. Most of the 10,000 plus Atlassian staff think primarily about products and customers, not apps and partners. Okay. So let's look at the challenges we faced given the context of highly autonomous teams and a customer-centric ethos. The key challenge is that we had a high rate of ecosystem incidents. In our terminology, an incident is a regression. Just pause there.
This flight now boards through gate lounge number 6. Qantas flight 520 to Brisbane is now ready to board through gate lounge number 6. Thank you.
Okay, go back to that side of the slide. The key challenge is that we had a high rate of ecosystem incidents. In our terminology, an incident is a regression causing impact to stakeholders. Many of these incidents were caused by shipping regrettable API changes. This quote is from one of the most experienced marketplace partners. I'll read it out loud. Atlassian developers are able to push out things at any point without anybody checking for impact. To our marketplace partners, it must have felt like they were in the Wild West. The causes of this boil down to two aspects. First, our API analytics coverage was weak. Due to their autonomy, different teams logged analytics separately, which led to many gaps. Second, the causes of many incidents was simply that the ecosystem was often overlooked due to the company's primary focus on customers. A slightly different way of looking at this is through the lens of the disciplines we lacked: API change management and collaboration. Okay, so let's look at how we've been solving these challenges. I started in 2021 by identifying two parallel streams of work: reducing the number of incidents and improving our API change logs. Of course, reducing the rate of incidents was the most urgent stream of work. It involved a lot of analysis of historical incidents to build a case and working with R&D teams to agree on how to define the various grades of incidents in the context of the ecosystem. This work also led to the standardization and centralization of REST API analytics, since it was necessary in order to be able to evaluate incident severity. The solution logs over 1 billion analytics events per day, and our tooling is able to calculate the potential number of apps and users impacted by any endpoint regression in less than a second. The second stream of work involved improving our API changelogs. The left-hand screenshot is what the Jira Cloud Platform changelog looked like at the end of 2020. We recorded over 5 changes all year. We recorded only 5 changes all year, 3 of which were for deprecations. The right-hand screenshot is what it looks like today. We've recorded 7 changes in the last 2 weeks, none of which were deprecations. So previously, we only logged the bare necessities, but now we are much more thorough. Teams are more aware of the need to communicate changes and consequently have a much stronger ecosystem DNA. The reason is that the new changelog solution is much easier for R&D teams to use. It has a friendlier editor, supports a review workflow, and allows future announcements to be staged. It is also backed by comprehensive guides such as how to choose the right kind of changelog entry, as well as guidance about editing announcements and splitting announcements. In addition to product-specific changelogs, our new solution has an aggregated changelog that allows partners to define filters and RSS subscriptions, enabling them to be notified in systems such as their own private Slack groups. These 2 streams of work led to a range of additional improvements. For example, colleagues produced additional practices, such as a request for comments process, whereby Atlassian teams propose changes so that marketplace partners can provide feedback early in the development lifecycle. We found that for the most part, Atlassian teams were happy to embrace the guidance we were providing. Our standards are adopted by teams, not imposed upon them. R&D teams don't lose their autonomy, but the standards provides alignment and consistency. I would like to think this was all achieved. I would like to think this was all achieved as a result of a master plan of mine, but the reality is that it was just a lot of defining guides, creating tools, and internal advocacy on an as-needed basis. So we realized we had established the basis of a set of extensibility standards. Our management had observed the benefits, and so we formed an extensibility standards team. My definition of extensibility standards is practices governing how APIs are designed and managed. This includes guides, processes, and tools to ensure our APIs meet a high standard, and any change to our APIs is managed properly, such as to minimize customer impact. Here are some examples of extensibility standards. We have quite a range of practices and tools, but we also have a long way to go. We have some major gaps in API design because we've been concentrating on where the need is most urgent: API change management and collaboration. Let's look at an example of an extensibility standard that involves generative AI. Our extensibility standards includes a definition of what a backwardly incompatible change is, and we ground this with numerous examples of backwardly incompatible changes. So recently, I've been exploring whether it is possible to use AI to determine if a change is backwardly compatible or not, just from the description of the change. If successful, we could incorporate this into apps we use to assist teams at various stages of the development lifecycle, such as when initially planning features, pull requests, and creating change log entries. Let's see a quick demo. This is the page where we define what a backwardly incompatible API change means. The page links to other pages providing definitions of relevant terminology. For example, here you can see a link to the page detailing how we define what API means. As with all definition pages, it also shows relationships with other extensibility standards concepts. It also links through to a page containing examples of backwardly incompatible changes. As you can see, there are a wide range of changes that can break APIs. This is the app I've created to see if generative AI can evaluate whether a change is backwardly compatible or not. The field at the top is where we enter the description of the change. Let's start with a simple example of adding a field to a REST API response. The AI indicates this change is backwardly compatible. This works by creating a prompt telling ChatGPT how to classify backward compatibility using a JSON representation of the examples defined in the page I shared earlier. The last part of the prompt asks ChatGPT to use this classification.
Ladies and gentlemen, Qantas link flight 2223 to Wagga Wagga is now boarding through gate lounge 16.
I'll repeat that. The last part of the prompt asks ChatGPT to use this classification to evaluate the description of the change. The app then parses the JSON returned by the ChatGPT. In this case, ChatGPT matched the statement to a classification which indicated field additions are backwardly compatible. Note that this is slightly controversial, since strict parsing may fail if it detects unexpected fields. The next scenario involves a change that removes a field from an API response. ChatGPT matches this change to the backwardly incompatible classification of payload schema changes, excluding field additions. The last scenario involves changing an API such that a state is reached after a delay instead of immediately. Here we can see ChatGPT has matched the change to two types of incompatibilities. The second match is correctly identifying that this change introduces eventual consistency semantics, so it's not backwardly compatible. The first match, however, is a false positive because there's no change to the permission scheme apart from the timing aspects. I've seen similar false positives when running this on some of our changelog entries, and what I've found is that improving the description of changes often reduces errors. So it could be that this approach has a dual purpose of helping improve change descriptions and helping team members correctly classify the backward compatibility of their changes. Okay, so let's recap with some lessons. And to be clear, these are lessons that I've learned along the way, but hopefully you will also get something out of them. First of all, while standards seem like they should be black and white, my experience is that there are often shades of grey. For example, we need to balance the speed with which we deliver value with the impact on marketplace partners. So as a result, our API deprecation periods vary depending on the circumstance. Our extensibility standards includes a guide and associated tooling that calculates the appropriate deprecation period based on information about a backwardly incompatible change, such as the reason for the change. As we saw earlier, there are even shades of grey in the evaluation of whether a change is backwardly compatible or not. Even when it is clear that a change is backwardly incompatible, it often requires judgment to estimate the actual impact likely to result. For example, perhaps a field is omitted from a REST API response. How important would that field be to apps? The next lesson relates to the challenge of getting adoption of our extensibility standards. Over 1,000 changelog entries in 15 products and services have been created with the new solution. R&D teams have created 26 RFCs since the start of the year with over 600 responses from marketplace partners. Our practices enjoy thousands of page views by numerous R&D teams, and our tools also get thousands of visits. However, there are still teams that don't recognize our standards, and every new standard will require an adoption strategy. Our experience has been that anything new must be clearly better than what it is replacing. Even then, adoption follows the typical S-curve pattern, whereby take-up is initially very slow, then picks up speed, and finally slows down again. You need to start with one or two champions that are happy to work with you to help iron out any wrinkles. You can then hit hard to get as many additional adopters as you can, but there will always be some that are resistant to change. You'll have to be prepared to loop back to these laggards from time to time to get them over the line. The next thing I became aware of is the variety of types of APIs and the fact that it's often the more obscure API types that are the most problematic. An example of an obscure type of API is what I call cardinality. Apps can be broken when a significant change in cardinality is introduced, such as suddenly invoking webhooks at a much greater rate, or introducing a new kind of object where apps were previously not expecting it. The incident analysis I did in 2021 indicated our authorization flows and front-end extension points were the most problematic types of APIs. Presumably, this is due to a combination of complexity and difficulty to cover with automated regression tests. The final lesson is that we have validated that extensibility standards has helped Atlassian, and presumably other organizations would also benefit from establishing...
Line 2262, the 1155 service to Lord Howe Island. This service is now boarding to Gate Lounge 1A.
The final lesson is that we have validated that extensibility standards has helped Atlassian, and presumably other organizations would also benefit from establishing extensibility standards. During the period we've been working on this, we've seen a significant reduction in incidents. Partner satisfaction increased from 68% to our target level of 80%. And whilst I can't claim the introduction of extensibility standards is the only reason for this, I am confident it was an important factor. So to recap, we've seen how extensibility standards has helped Atlassian R&D teams, our ecosystem partners, and our customers. We set out to fix API instability, but we've seen benefits well beyond this. I doubt this story is unique to Atlassian, so I'll leave you with this question. Will you establish extensibility standards? Thank you.